Hi all, my name is Nikhil Krishnan. I am a faculty member at IIIT-Bangalore. Today, I will be giving a quick overview of one of my research areas, namely codes for streaming. Consider a packet erasure channel. There is a sender and there is a receiver, and the sender would like to transmit a sequence of message packets or data packets to the receiver. At time 0, the sender is transmitting some message packet M0, and it successfully sends that message packet to the receiver. At time 1, the sender is having another message packet M1. However, it turns out that the message packet got lost during transmission. In other words, we say that the packet got dropped or erased. Clearly, this is an undesirable situation, right? So how can we tackle this issue? One may think about retransmitting the lost message packet, right? But there is an issue there, and we will see that right away. So let's assume that our sender and receiver are at diametrically opposite ends of the earth. Initially, the sender is sending the message packet to the receiver, and let's assume that the packet got dropped. The receiver can now perhaps send a feedback to the sender, and based on the feedback, the sender can now attempt a retransmission. So clearly, there's a three-way delay here, right? Even if the transmission is happening at the speed of light, still there will be a total delay of roughly 210 milliseconds. International Telecommunication Union, on the other hand, recommends that for interactive video or audio applications, the delay should be less than 150 milliseconds. So clearly there is an issue here, and retransmission is not helping. And this is precisely where coding can help. Let's now see how coding helps. At time 0, instead of simply sending the raw message packet, the sender will now append a few extra bits in the form of a P0. So along with M0, we also have some P0. And it's sending that larger packet. And let's assume that it got successfully sent. At time 1, again it's sending another larger packet. This time we are adding an extra P1 along with M1. Similar to the previous case, let's assume that the packet which is sent at time 1 is getting lost. At time 2, the sender is transmitting another packet, this time P2 along with M2. And let's assume that it got successfully sent. And now the interesting thing here is that because of those extra symbols or extra bits that we sent, right, P0 and P2, it turns out that we can recover the lost M1 at time 2. Codes for streaming or streaming codes are basically a class of packet level erasure coding techniques which enable reliable low latency communication. It basically permits recovery of each lost packet or each erased packet with a strict delay constraint. Where can we apply these codes, right? We can obviously apply them in interactive voice and video applications, right? For example, Skype, Zoom, etc. It can be applied in augmented reality scenarios. It can be applied in multiplayer gaming, and the options are virtually endless. What are some research opportunities in the area of streaming codes? One thing to be noted is that the conventional coding schemes, such as the well-known Reed-Solomon codes, yield suboptimal performance in the presence of bursty packet drops or packet erasures. So because of that, there is a need for dedicated coding schemes, and this is precisely where streaming codes are coming into picture. And one natural research direction is to construct practical, easy to implement streaming codes and also to test them out in real applications. Thank you.
Hello everyone, I'm Prem Singh, Assistant Professor at IIIT-Bangalore. In this video, I'm giving an overview of Open Radio Access Network compliant distributed unit for 5G base station, which is being designed at IIIT-Bangalore. So if we look at a typical 5G cellular architecture, there is a base station, there are users, and these users are connected to the base station using a wireless link. So there are often functional split within 5G base station, including RRH, which is remote radio head unit, and BBU, which is baseband unit. One RRH can cover a sector of 120 degrees. So there are 3 RRH are required to cover a complete cell site. Each RRH is connected to the BBU using a front haul link, whereas BBU is connected to the 5G core network using a backhaul link. One BBU can control 3 such cell sites as shown in this figure. Thus, the 5G base station, which is known as G node B, consists of 2 logical units, RRH and BBU, and which communicate to each other using a front haul link. The software at 5G base station has to perform file layer processing, MAC layer processing, link layer processing, resource link layer processing, and these processes are commonly referred to as L1, L2, and L3 layer processing. As shown in this figure, the 3GPP standards specifies different functional splits, which determines the amount of functions performed at the BBU and the RRH. For a particular function splits, as shown in this figure, the functions on the left side of the dotted red line will be performed in the BBU, whereas the function on the right side of the dotted red line will be performed in RRH. So whenever we select a particular functional split, there exists a trade-off in terms of front haul bandwidth and RRH complexity. So in nutshell, a base station is a set of boxes used to connect smartphones and devices to cellular networks. These boxes are primarily manufactured as a single entity and are sold primarily by telecom giants such as Ericsson, Nokia, Samsung. To expand 5G network more cost effectively and faster, these days the concept of Open Radio Access Network, called Open RAN or ORAN, is a hot topic in mobile telecoms. The ORAN supports interoperations between vendors' equipment, which allow the industry player to build different building blocks independently. So as shown in this figure, ORAN consists of 3 building blocks, namely radio unit, which is there at the bottom of this figure. This RU is located near the antenna and it performs low-fi processing and radio frequency functions. The second block is distributed unit. It can be located at or near the RU. It handles hi-fi layer processing and lower L2 processing. Hi-fi layer processing include LDPC, rate matching, scrambling, modulation, layer mapping. And the third building block of ORAN architecture is called centralized unit. It can be located near the core and it performs higher L2 and L3 layer processing. We at IIIT-Bangalore are designing distributed unit for the 5G base station design. So the objective of these projects are, the first objective is to design hardware for distributed unit to support 5G and beyond applications. So our distributed unit will comprise of an FPGA based baseband card and a server. The baseband card, which is being designed at IIIT-Bangalore, will perform all the hi-fi layer signal processing of distributed unit, whereas the server will perform L2 and L3 layer processing. The DU being designed will support both the sub-6 gigahertz and millimeter wave band operations. The second objective of this project is to design 3GPP compliant 5G NR physical layer algorithm for control and data transmission and reception in distributed unit. This in particular includes design of physical uplink control channel that carries control information from user equipment to G node B, development of physical downlink control channel, that is PDCCH, that carries control information from G node B to user equipment, then design of physical uplink shared channel that carries data payload from user equipment to the G node B, and design of transmit PDSCH, that is physical downlink shared channel that carries data payload from G node B to the user equipment. The third objective of this project is to test the designed 5-layer algorithm on the custom hardware which we are designing for distributed unit. So this was the overall idea of the project being carried out at IIIT-Bangalore. So the research positions are available for the prospective PhD, master's, and undergraduate student. So if you want to work in physical layer and if you are interested in this work, please drop me an email with your CV. Thank you.
Hello, I'm Dr. Vinod, an assistant professor at IIIT-Bangalore since 2018. My research interests include signal processing for radars, biomedical ultrasound, and other sensing modalities. Okay. And at IIIT-Bangalore, we have a lean radar lab where we work on some cutting-edge research problems. As you are aware, radars have been extensively used in commercial applications such as industrial as well as in automotive context. In automotive context, both in autonomous driving vehicles as well as in advanced driver assistance systems, radars have been an integral part. Right? This has opened up several problems and opportunities for the team to work and make a significant impact. We have tie-ups with Continental, Veoneer, BL, to mention a few. And yeah, besides automotive context, our team has been working on some research problems such as UAV detection using radars and multi-target detection as well as tracking, microdoppler signature analysis, to mention a few. Yeah, we look forward to expanding our team with passionate people who are very much keen to work in this particular field. We would look forward to candidates with strong background in signal processing, hardware familiarity, embedded systems, and machine learning and deep learning enthusiasts. Yeah, do reach out to me. My details are on the institute website, right? And I will now take the opportunity to introduce my team members.
Hi, I'm Surya. I've been pursuing my MS by research with the radar team since 2019. My research area of interest include radar signal processing. So with the radar team over the past few years, I've got to work on various projects such as FMCW radar for microdoppler signature extraction and multiple target tracking. So while working on these projects, I got exposure to radar cards for data collection and radar signal processing for real data as well as for synthetic data, and also on how to apply deep learning methods for radar data. Thank you.
Hi, I'm Nini. I've been working towards my PhD with the radar team at IIIT-Bangalore since September 2020. My research interests include radar signal processing, RF and microwave engineering. For the past 1.5 years, I've been working under Professor Vinod on multi-target detection in a noisy environment with different types of models like that of a car, truck or a bike. Real-time scenarios were assumed and the radar cube data was generated. deep learning approaches have been employed for the target detection and prediction. Thank you.
Hi, I'm Sriram from IIT 2018. In the radar lab, my area of work has been in deep learning for multi-target tracking. So multi-target tracking is a very important problem with defense and automotive applications. And here we use sequence models to improve the existing traditional methods. And with my exposure to computer vision, I'm also looking forward to work in sensor fusion with camera and radar.
Myself, Abhinav Dikshit, and I have joined IIIT-B in 2021, and I've been working under Professor Vinod sir. And my area of research is the vital sign estimation, and just looking forward to have great time in this research area. Thank you.
First of all, welcome everyone to the RISE event 2022. I'm Vinu Venugopal. I'm an assistant professor at IIIT-Bangalore, currently focusing on big data systems and large-scale data analytics. I'm also associating with the Web Science Lab of IIIT-Bangalore for their various projects. My PhD was in the areas of description logic-based ontologies, knowledge graphs, and semantic web technologies. And I later moved on to more system-oriented research at the Big Data Research Group of University of Luxembourg before I joined IIIT-Bangalore. My research here is focusing on building data processing systems that can sustain an exorbitant amount of input throughput. So typically, when a system tries to ingest a large amount of data, which it really cannot sustain, it would end up in a state called backpressure. So what you can potentially do here to increase the sustainability range of such systems is by having more advanced and asynchronous system architecture that can process the data in less time without buffering it too much. So this is one area we are profoundly working on. And the sustainability range of the system here would greatly depend on what kind of use case we are interested in, whether it is just a set of standard data flow processing operations like filter, map, etc., or an online training of a deep learning model, or even reasoning tasks performed over the streaming data. And all this needs to be done in a distributed and heterogeneous node setting, which makes it much more complicated and which also imposes a lot of challenges, right, from having an abstract model for representing your use case. So in addition to these, I'm also working on projects that are related to these key areas. So if you are really interested and motivated to work in these areas, you can of course contact me via email. And thanks a lot for listening to me, and have a good day.